Okay, and we're COMP2068, and this is week 4, lesson 4, part 2. And now I'm going to talk about some object-oriented JavaScript, which we need in order for us to move forward. I'm also going to talk a little bit about TypeScript, and then the third piece of this is we're going to talk about Create.js a little bit more. Okay, so what is this object-oriented JavaScript that we speak of? Right? I want to talk about this with you a little bit. I'm going to, in the meantime, let me do a couple of things. I'm going to clean up a couple of things that I just did. I'm going to go into my repositories and get rid of imadummy.github.io. I don't need that. How do I get rid of stuff? One of you guys asked me that before. I go in there and go to settings. This is inside my repository. I skip down to danger zone and then click on delete this repository. And then I put in the exact name of the repository. Okay, and then click, I understand the consequences, see you later. Right? Now that's gone, so I don't have that one anymore. But I need a new one for today's lesson, so I'm going to kind of do that again. So I'm going to go new repository, and the new repository obviously is going to be the name of today's lesson as soon as GitHub responds to me. COMP2068, lesson 4 is what we're at right now. This is where it's going to be. And you know what? This lesson is all about object-oriented JavaScript, right? So we're going to use that, and at the end we're going to kind of make a TypeScript file to show you the difference. Okay? So let's cater this and make this like part. We'll say part 2, because this is what this really is, part 2. Right? First part was GitHub. Okay, and create repository. So once I've got that, I've got this nice little URI. I'm going to take it and copy it. And I'm going to go back into Visual Studio and now create my new project. Here it is. And when I create my new project, we're going to go onto the web stuff. I'm going to go into ASP.NET web application and create something that looks exactly like I just made. So COMP2068, lesson 4, part 2. Right? Lesson 4, part 2. And press OK. Okay, and in here, I'm going to, as soon as I get through this, I'm going to start things from scratch yet again, right? I'm going to go to Solution Explorer, and inside my Solution Explorer, I'm going to right-click, right? And inside there, inside my Team Explorer, let me do that part first. I'll go Changes, and here's all the changes that come with my basic project. Initialized basic VS web project. Right, that's what this is, commits. Okay, and then I go to my home and I click unsync commits and I drag and drop my URL in here, or copy and paste is what I mean, and then sync it up. So now if I go to GitHub, you guys can follow me live. I've got lesson 4, part 2. That's what this is going on, right? Okay, cool. I'm just going to kill this for now, and I'm not going to go back to it for a while. Okay, so here's what I'm doing here at my Solution Explorer. Remember, when we set up a file, let's do it together again for one more time. I'm going to create my basic structure for my web project, and I invite you to do it with me. This is the lab piece, the lab portion that I invite you to try. You need to get really comfortable at doing this over and over again, because when it comes down to doing a test or something like that, if I was ever going to do like a little exam with you, you'd have to kind of put up something really quickly, and you have to do it here on the fly, right? So again, I'm going to go right-click onto the project piece, add, and then from there I'm going to add a new folder. I've got to have some CSS for my file, right? Let's do that again. Right-click. I'm going to add, and I'm going to go new folder, and it's going to be assets. I want to get you used to that. And again, I'll add the rest of the stuff really quickly. The other piece is scripts with a capital S. And so assets, CSS, and scripts. In my assets, I want a couple of things in here. I want images and audio, which we're not going to have right now, and also fonts. I want you to get used to doing that, almost creating your asset library. It's empty right now, but that's okay. And in my scripts, I'm going to add in another library called lib for library. Okay? Okay, cool. So I've got my basic setup. I'm going to also right-click and add a new index.html file. And remember, when we do that, here's my HTML file. Visual Studio kind of kicks out this stub file that's useful for many things, but we want to kind of adhere to the best practices of HTML5. So we go language is English, and our meta tag we have to put in here as well. Our meta, I'm going to do a character set. I want to define UTF-8 because that's the character set we need. And I'm also in my meta tags, I'm also going to put in a name is equal to viewport just to handle mobile stuff, and content is equal to width is equal to device width. Initial scale 1. Okay, so I've got that basic stuff in there. My title is going to be the name of our project, which is COMP2068, and it's lesson 4, right? And in my head, I want to put in, underneath my title, I got to put some CSS in there. So again, just from practice, here's my CSS section, right? And then inside my body tag, in here, I'm going to put in my JavaScript section. Okay, here's my JavaScript section. So my CSS section, my JavaScript section, and now I got to create those files. So I'm going to right-click on my CSS folder and go into Style Sheet, and just we'll call this game.css. Right now it's kind of empty, and I'm going to drag and drop game.css underneath my CSS section, right? Because I want to kind of include that. And inside my JavaScript section, I need a file, so I'm going to go right-click on scripts, not on the library part, just on scripts itself. Go Add. And then I'm going to add a new JavaScript file. So we're going to work with JavaScript right now. Okay, and then we're going to call this game.js. We're going to do this all again when we create our template, if you will, or our boilerplate for create.js after. Okay, cool. But I need to link this file, this JavaScript file. I need to link this in my JavaScript section. So I'm just going to drag and drop it, right? So now it's linked up. Okay, cool. But it really doesn't do anything, and the way to do that, of course, is add a little listener to the body tag. And the way we're going to do that is to say, just to make it easy, is onload, right? And we're going to define a new function that we're going to call init, that we're going to launch. That's the init function. We haven't defined that function yet. This is where we're at right now. Take a look, guys. Init, right? And there is no function init here. I got to create it in my JavaScript file. So let's do that. So I'm going to go back into my JavaScript file in my game.js. Here it is. And I'm going to kind of space down a little bit. Remember, JavaScript doesn't care for white spaces. It ignores them, just like most compilers, most modern C-style compilers ignore JavaScript, or sorry, white spaces. And they also ignore comments, right? That's the same thing with JavaScript. So we're going to put in a new function, and we're going to call this init, just like we did last time, and kind of put in a couple of brace brackets here that we can use for our code block. Okay, so this is our function. And you know what? We're going to do a console.log just to send something out to the console to show that we've gone into here, and we're going to say game started. Right? We don't need to do this, but just to prove that we're able to access this function, right? It's going to kind of do this thing first. This init function is going to run. That's what I'm saying here. As soon as my body is loaded, so as soon as my body tag hits this command, this line number 10. As soon as this line number 10 is hit, it's going to access, it's going to remember, it's going to listen for this onload event, which means the body of the content of my page is loaded, and now I'm going to send it to my init function, which is inside my game.js file. That's all it's doing. Okay? So let's run this thing to test it out. So if everything goes well, I've got a blank page. Great. Let's take a look at, see where if I go to more tools and I go, and this is in Chrome, and I go to JavaScript console, inside here I see game started, which means my JavaScript is good to go. I've enabled it. I'm able to access my function that's inside my game.js file. Are you with me? So if you're not with me at this point, I'm going to lose you in a second, right? Okay, so that's great. So we've set up our basic thing. If you're not with me or you couldn't follow along, so it's too quick for you, I'm going to go into my, I'm going to stop debugging here for a second, go into Team Explorer, go to Home, go to Changes, and making sure that I have no untracked files, I'm going to say created basic site structure. Okay, and then commit, go to Home, go to Unsync Commits, and go to Sync. And once I've done that, my workflow is complete. It'll sync up with the GitHub files online, which you could certainly go to and kind of pull down from if you want to match things up with me. Okay, we're done. So let's go back over to our PowerPoint and take a look at this thing a little bit closely. So again, a really quick review of object-oriented programming. I kind of hit this a little bit last week, but I'm going to do it again. Namespace. Really, if you think about a namespace, but let's think about it as a container or a folder, if you will, where everything is contained. All right. So physically on your hard drive, it might be a folder. That's the namespace. But really, it's a container which we bundle everything together. All our functionality is in this one container that we can access. So if I want to access classes, I can access them within within this container. On the Java side, if you're taking Java with me, they're called packages. Packages is the namespace equivalent to what we're talking about here in JavaScript. Okay. Class. We know what a class is. It's a blueprint, like we talked about before in object-oriented terminology. We know what an object is and a property. Again, sometimes a property in one language is an instance variable in another language. For example, in JavaScript and C#, they're called instance variables. A property might mean something different. A property needs to have getters and setters, right? That's the difference between an instance variable and a property at a very high level, okay? Then you have a method, which is something that does something, right? So just to remind you what object-oriented terminology is. We have a constructor within object-oriented terminology as well. And inheritance, encapsulation, abstraction, and polymorphism, all these things that we know. And they're all available for us in JavaScript, but in a different way. Why? Because JavaScript is a prototype-based programming language. It's not a language that has classes at this stage in the game. Right now, we're sitting at ECMAScript 5.1, if I'm not wrong. And ECMAScript 5, which is where JavaScript is based on, and most C-style languages these days, including Swift from Apple, this one is a classless, prototypical, or prototype-oriented language. So there are no official classes in JavaScript. We use prototypes. Now, all that being as it is, we still can do many object-oriented, perform object-oriented behaviors with JavaScript. I'm not going to go too much into the heavy workings of JavaScript, but let's talk about functions a little bit, because before we do objects, we need to understand functions, because functions are funky in JavaScript. They're a little bit different than when we remember them in other languages. So a couple things. Again, a function, it takes arguments, and again, sometimes if you can have either return something or not in JavaScript, right? And the way we use our general form for a function looks like this. Take a look, guys. Right? You might be very familiar with this form, right? Except this isn't the only form that you might see in JavaScript. This, all right, and is the function. We're using the function keyword here, and we're using the function name, right? And then with these parentheses, this is where you put in your parameters as normal, as you'd expect for any C-style language. And between the braces, your statements go and they're executed. Yeah. But functions can also look like they're different beasts. They can also take a number of parameters, parameter 1, parameter 2, to parameter n, right? And when you call a function, you call it like this, value 1, value 2, just like we normally do. But what about when you don't send functions? You don't set up function parameters, like this. This is your function. I don't set up function parameters, but yet I can accept parameters. Well, in JavaScript, you're able to do that. And this is where programmers go nuts, right? They look at JavaScript and they go, wait a minute, you didn't set up, you didn't in your function declaration block, right? In your header, right? There's nothing that says anything about parameters. Well, you know what? JavaScript implicitly creates an array of parameters for you, whether or not you send parameters in there, which is sometimes good and sometimes bad, right? Which means whether or not you send it in there, you can set something else. There's a keyword. There's an arguments array that automatically is set up for you, that it's 0 index, just like this, and you can actually set up variables for this. So for example, my first argument and my second argument is equal to the arguments array, which is built in, of 0. Right? So example, if I was to do that here in Visual Studio, I'm going to go into game and set that up. Right? So I'm going to say, and let's just start typing and see what happens. So var my first arg is equal to arguments. Hey, look, it comes up. There is no arguments, right? Argument 0. right? You can do that, and it comes up with code hinting, right? I don't have any arguments defined here in my function, but because I'm using JavaScript, now I do, right? People go crazy for this stuff, and this is why when I talk about TypeScript a little bit with you guys and said, hey, TypeScript is syntactic sugar, right, for JavaScript. It gives us the ability to stop this stuff from happening a little bit, right? Because this is confusing for beginner programmers or people who've just started using the web. They're looking at it going, that doesn't adhere to what we normally are used to. That is not right. But this is the beauty and the ugliness of JavaScript at the same time, because JavaScript can be very flexible, whereas other programming languages are very strict, right? So again, someone might say this is ugly, and you might talk about a pure JavaScript vanilla kind of JavaScript developer, and he might say, oh, no, that's the beautiful piece about JavaScript. It gives me flexibility to do whatever I want to do. The bad thing about this is that everyone does what they want to do, so when you look at code online, you're like, what the hell? You don't understand what's going on, right? For most of us, it becomes almost like a jumble, like spaghetti we're looking at instead of code. So this is what you can do. You can totally do this. Do I recommend that you do this with your code as we go forward? I don't recommend it for us here as programmers, kind of taking on JavaScript as something we're going to use to create our games and so on, our interfaces. Although in a pinch, if you had a workaround, if you were stuck, it's not like you couldn't, right? So we have the capabilities, but I don't recommend we use them unless we absolutely need to, and we can't figure out another way that's better and more object-oriented. We'll talk about that in a second. So here's another way you can do it. You know that there's an arguments array. I'm going to talk about it because it's there, right? Well, if it's an array has built-in methods, like the length method that comes with all arrays, right? Well, you can say you don't know how many arguments you're taking in instead of naming the arguments, and you could cycle through all the arguments, every one of them that you take in, an unlimited number of arguments that come in. It can be from 0 to whatever, and as long as the arguments array is less or is greater than 0, right? It'll cycle through this for loop, and it'll do something for each of the arguments. Okay? So you could do it that way as well. Leave scope up for, I'll let you guys read that a little bit. Return values. As we know, like any function, arguments or functions only return one value in JavaScript. Now, in other languages like Python, you can return multiple values. You could still return, in a way, multiple values here in JavaScript, but you have to return an object or an array back of array of objects, an array of data type objects. And so that where you are returning multiple values, as opposed to multiple variables, right? So you can't return multiple variables normally. Now in Swift, in the Swift language that we're going to be learning in the other class, you can return multiple variables because you have something called tuples in Swift, which you do not have here in JavaScript. Remember, in JavaScript 6, which should be coming out fairly soon, we're hoping this year by July, August timeframe, they will have something called tuples, hopefully, right? And when we have tuples, then you can return multiple return values through a tuple. But here in JavaScript, we don't have that capability. You can only return one value or one object back into from the calling function. And this is an example of how we do that, using the return keyword. Okay, but you can also use the return keyword more than one time. Like for example, in this particular example, if this x value is equal to 1, when we return true, and if it's not equal to 1, then we return false. Right? So for everything else, actually, whatever it's equal to, even if it's equal to 0, 1, -1, a, whatever, it's going to still return false. Right? And this is a legal way of writing things in JavaScript. In some other languages, you would not be able to do this because you're using two return statements within the body of your function. Although in most modern language nowadays, this is safe to do. And again, from a return values perspective, you can put the return statement anywhere you want in the function, which means that this line here, var count equals 0, would run. Var first num is equal to 48 would run. You put an empty return statement that would run and return you back to the calling function, right? And yet this lonely stepchild, var second num is equal to 109, would not run because it would never get there. It would return back to the calling statement before we get there. So be careful. You want to try and put your return statement at the end of the function, although it doesn't have to be, right, for JavaScript, which is a bad thing for most programmers, right? Because they look at it and go, that makes no sense. Why do you put stuff under, beneath the run or beneath the return? And people do that by accident. So be careful about that. That is a common error. And it won't kick back a syntax error, right? It'll just be a logic error for you. It won't work the way you think it's going to work. And you're like, how come it's not running? It's there. Look, it's inside my statement. It's inside my function. Well, yeah, because you get the return before it. And it's going to return control of the program flow back to the calling or the invoking function or the place where this function was invoked. Okay, more on calling functions. Hey, we saw before, right? We saw before that we can, this is where we return values. So I call the function here, and this function with the assignment operator is going to take the value, the return value of the function, and return it back to this result, right? So as an example of that, if I pass in two parameters, type and quantity, I might get back, I'm hoping to get back the result or the return value from this function back into the result. This is how it would look. But be careful, because if you use the result equal to the order fruit function without the parameters, what am I doing here? What am I doing here? I'm not returning the value of order fruit. I'm creating a new alias for order fruit, the order fruit function. I'm renaming it, in fact. Now my result variable is also the order fruit function. All I'm doing is creating a pointer to point to the order fruit function, which is not what I want, typically. Unless I want to create an alias for a grouping of functions and classes to make it easy on my life. Like, for example, if I wanted to make create.js, if I wanted to make, I want to create a, I don't know why I would do this, but let's say I wanted to say C, the value C, a global variable C, is equal to create.js. Right? Instead of me typing create.js all the time, I can make it C. I could say var C is equal to create.js, and now I have an alias for the create.js class and framework. So then, if I want to do something with create.js, instead of doing create.js.stage, I could simply do c.stage. Right? You might see that in some places. I don't recommend it for beginners. It would screw you up. You might look at it and go, I don't understand what I'm doing. Why is this working and why isn't it working? I don't recommend it. But this is what happens. You create an alias for this thing as opposed to actually getting a return value like total. This would never return anything. It would just make this is a pointer, this is an assignment statement that says this order fruit function is equal to, it's going to, result is going to point to a new pointer, an alias for this order fruit function. That's all this means. So please know the difference between this, which is actually returning results, and this, because you have the parentheses here, and this with no parentheses that creates an alias for the function. Okay, so that's something that we want to talk about, and I got some funky formatting here going on top of my code. That's okay. So functions so far we've seen are formally defined, but what about this? You might see this kind of situation right here. Here's a function. I'm just going to kind of fix that because it's bugging me. I don't know how that formatting happened. Oh, the Mac, lovely, lovely Mac. Anyways, let's go back. So if you notice this function here, right? The anonymous unnamed function idea here we're talking about. We have a variable div_nums. That's what it looks like. If in regular code, if you looked at this as a regular program, you go, how can I assign this function to div_nums? What does this mean, right? Well, what am I doing here? I'm not getting a value, right? This is the regular way that I would think this function div_nums. I'm actually using the function keyword here, but there's no function name. So what I'm doing here is I'm declaring a new function, header, and I'm saying that div_nums is actually an alias for this anonymous function. Yes? It's way down here. Oh, we mean, no, it should be here, actually. Thank you very much. That is not intentional, I said. And we will ignore that one. Thank you very much for this. When I actually upload it to you now, it'll be perfect. Yes, so this is, if you notice, I'm making a function, but it's an anonymous function. It's not a named function. I'm using div_nums as the alias for this anonymous function. And you might say, hold on, Tom, what is an anonymous function? It's a function that's not a named function. It's a function without a name. It uses the function keyword with a constructor, a parameter block here. That's what this is, right? But there's no name for it. It's not like the regular way we see it is function, the keyword, div nums, and then this stuff. But this is the other general form that you will see lots and lots of around the web. This general form here, which screws people up. They go, I don't understand why that function looks like that. It should be function first, right? Because that's the regular way we expect it as programmers. Closures. We have to talk about closures a little bit. And closures are the ability for you to have functions that are nested within JavaScript, which is, now if you were messed up before, now you're really messed up. You're like, hold on, I got like function, and now I got a function within a function. It's called a closure. That's what they're called. And not only is it a closure, but guess what? This function here is an anonymous function, right? So there's an unnamed function which is inside this closure. How does this work? Well, when I call, I use this funky way of saying this. I say call func, right, which is my variable, is equal to my function, right? That's what this thing is. Call func is equal to my function. This is really weird, right? When I call it, my function is called. I declare my variable, my num, is equal to 10, right? Now this, what scope do I have for this my num, right? What scope is this? This is within this body right here, right? Between this little brace and this little brace here, right? That's where my num lives and dies, right? Well, guess what? It's also available to this anonymous function, which gets called right away because I don't have to call show num, right? Because show num doesn't have a, it's an anonymous function that gets called right away, right? Okay, cool. So now show num gets called, and it creates this alert that takes the value of my num, which is equal to 10, and pops it onto the screen. So in effect, what I'm doing when I'm calling my function is I'm actually calling this function here, this anonymous inner function, or how we classify it as closure. Yeah? Woohoo! Be careful. Be careful, I said. Why? Because I'm returning, and the only reason why this is happening is because I'm calling show num right here. That's the value I'm returning, right, in my return statement. Guys, I'll try to avoid this syntax for you as much as I can as we go forward. This is confusing syntax that most programmers look at and they want to bite their own head off, right? So if they could do such a thing, right? Yes?
So,
how to call this div nums? Right, you just call div nums and then you would put the two arguments, or if you're using JavaScript, just call it with or without arguments. It's the same thing, right? But you would call div nums. Div nums is actually the name, the alias for this anonymous function. It's not a named function. It's an anonymous function that I've given div nums, I made div nums the alias for, right? A pointer to this anonymous function. Crazy. All right. I'm not going to go too much in there. Let's talk about methods. So we talked about functions, but maybe methods really are functions in some way, right? But the thing is with methods, we can kind of access methods of classes with the dot operator or the dot notation, just like we do in other C-style languages, right? So built-in objects, there's a bunch of them, math, date, and string. I'm not going to go into detail on what those things do, although we will be using the math.random function very frequently in our gameplay, right? And some dialog functions I put in here. I'm going to let you read this piece yourself. Let's talk about objects in JavaScript now before we finish off this piece. All right, so we talked so far about functions, and you need to know functions in order for you to have objects, because you know what? Guess what? Functions are prototypical behavior for JavaScript. It looks like functions, right? So if you don't know functions, then you can't understand objects. That's why we did the function piece first. Because remember, functions are weird. Hey, functions in JavaScript are funky, right? They're different than what we see in other languages. Okay, so there are two ways to declare objects in JavaScript. There's two different notations. One, like this one, right? Where you say var star, the variable star is equal to a new object. We've seen this. This is a very common way we see in other languages, right? And we can also do this, which you probably have not seen in other languages, which is var star is equal to these curly braces. Well, if I do this, it's equivalent to this, right? In fact, this is becoming largely more popular than this in JavaScript right now. Why? Because it's simpler. It's quicker. It's also crazy. But we'll talk about why it's crazy and what the advantages are of literal notation over constructor notation. So here is what literal notation looks like. All right, and I've kind of put this together for you guys to see. Var hotel is equal to this curly brace. And there's the other curly brace down here with a semicolon at the bottom. And if you notice, I'm declaring my properties here. Here's properties. Name with colon and then the value. So what does it look like? Key value pairs is what it is, just like a hash table, if you will. So here's our dictionary, right? So here's my key, name, with a colon, and here's my value separated by commas, right? And even here is my internal function or method, check availability, right? That's a function, an anonymous function, with a function body. So this is our method, and these are our properties. Yes? Does it accept? Because you can do single quotes key or double quotes. It accepts both for JavaScript, depending on what you feel like. Yes. It doesn't do triple quotes, though. Triple quotes are only available in Python, right? But yeah, it does single quotes or double quotes. You can't use both. You can't say like a single quote in the beginning and a double quote at the end, a syntax error. Or else, actually, it won't kick up a syntax error. It'll work, but it'll be ugly, right? And you could cause other issues. So again, there's two things. So here's our object. Look how this is color-coded. Our object is this yellow piece right here, our hotel, right? And then we have our key and value pairs right here, key value pairs, right? And this is the same way. So when I invoke this, when I create this object, what am I doing? I'm creating a new class. And you know what? I don't have a constructor for this class, right? I don't have a constructor, right? My hotel, when I use this notation, I'm actually creating these key value pairs and also this inner method called check availability, right? This is a very legal way to declare an object in JavaScript. And actually, if anything, if you look at it, it gives us the ability to create a new data type of a way, right? Think about this as us creating a new data type. Actually, we should think about that when we create an object in any language. We're creating our own custom data type. So that's literal notation, which is by far the most popular way to create it in JavaScript objects on the net. If you look on the net, you'll see stuff like this all the time, right? Confusing for most programmers, though. You look at it and you're like, I don't get it. What is this? What are we doing here? Is this? Am I declaring a list? It looks almost like a list, like an array, if you think about it, right? It looks like an array of items, right, that have key value pairs to them. The only thing that would give it away maybe is this function thing right here, right? But otherwise, it's a big list or an array, right? This is where it becomes very powerful to use JavaScript. You can use JavaScript in this way, and once you start using this literal notation, you can realize how powerful it is to do such a thing. Because when you do this, what are you doing? You're creating a new namespace. And this namespace, so between these two brackets, this bracket here, this curly brace, and this curly brace down here, we've created an alias for these two brackets, these two braces, and we're calling it hotel. It's a different way of thinking, right? It's not like we're creating an object, right? We haven't even instantiated the object. If you think about it, when you think about it in your head, you're like, this object hasn't been instantiated. Yes, it has. Once you use the equal operator and you put these curly braces like this, you've just instantiated a new object called hotel. That's it. You're done. Your object is made. And I can start using it right away. I don't need a constructor. Here is what we're normally used to. Constructor notation, right? Where we use our hotel. This is our object. We need to use the new keyword. And we need to use the other keyword called object. Well, actually, it's not really a keyword. It's a built-in object that's part of C-style languages like Java, C#, and so on. It's the super class that exists for all objects. Object, right? So it's a new object. And what we do here, we use the hotel keyword, right, which is our new object, to create variables or properties, instance variables or properties for our class. And again, you see this whole name, a key value pair configuration. We're using the dot notation to denote that it belongs to the hotel object or class. And the same thing goes with this function, hotel.checkAvailability. This is just a different syntax that you'll be seeing, is equal to this function. And then, of course, we can use the this keyword, right, to talk about this room right here. When we say hotel.rooms, we're actually saying this.rooms is equal to 40. And we can use the this keyword, like we do in other languages, to create this calculation. Again, better for some programmers when they look at it, Still might be confusing because you don't have a constructor, a classic constructor. You don't have such a thing, right? Even though it's called constructor notation. Okay, so let's take a look at some examples. We've got star.name. Okay, star.name is equal to Polaris. Okay, and star.constellation if I created a star class. And how would I do this in constructor notation? If I go back to the beginning, right, way back over here, here's where I declare the stars, right? It's the same way, whether I do it this way or this way. Now, when I go over here, I can still say, I can declare this key value pair, this name key, is equal to Polaris, this value. I can declare this constellation is equal to Ursa Minor. But I didn't declare them over here, right? I only declare the objects. Well, guess what? You don't have to. You can, as soon as you assign them, now they're properties of this object automatically, right? They just become. You've just created. If it doesn't exist, JavaScript says create it, right? Bad, right? We look at it and go, oh my God, how can this happen? I'm ready to cry in a corner. It's bad, right? Because it doesn't make any sense that this thing should happen this way. It doesn't make sense from an object-oriented perspective. Guys, this isn't object-oriented. This is prototypical. It's a prototypical instantiation. Okay, so here we are. We're down here. We've done this. That's perfectly legal. And of course, I can check to see if a property is inside of an object. I say if my property is in an object, I can use the in operator, and I can do something to it. So I can check to see if an object has a property. Actually, some other languages do the same thing as well. Okay, let's take a look at adding methods to objects, right? So again, we did the same kind of idea. We said, here's our function star, which is our object, right? And we have a couple of things here. We have this constellation, which is, and by the way, this is, look what this is here. This is our constructor, right? This is our constructor. Function. When we say function star, and we put something inside of here, this is another way to declare our new object, right? And because it's a function, and now we start assigning properties, this constellation, this type, this spectral class, this magnitude, and so on. And now here's this show, which is a function within a function, closure, right? Like we talked about before. This show method, right, is something we can call down here, star Polaris.show. We can say, you know, send Polaris. We want to look at the Polaris, right? That's what we're looking at, and show, use the show method to alert to use this method. And by the way, all we're sending in, here's another thing, if you notice. I don't send in every single thing here. I'm assigning, right, my star, right, and I'm assigning Polaris as the constellation here. That's what I'm doing, right? I'm doing that here because that's the first one that I'm using. I'm using this square bracket notation to call the method. Weird and unusual, right? I'm not going to talk too much more about arrays. They're here, and the reason why I bring them up only because they're kind of a built-in object that you should know about. One thing to know is this: arrays in JavaScript, which we'll be seeing as we create programs, we create code, right? They're very flexible. They can hold other objects, just like other languages, right? So imagine that if I want to have an array of aliens, right? Well, I can do that. If alien is an object, I can put as many aliens or images or audio or whatever inside each of the memory locations in my array. Not only that, but they don't have to be even contiguous in terms of the way they are. They don't have to be all of one data type. They can be an array of aliens. I can have some aliens in there. I can have some heroes in there. I can have some images. I can have some audio. I can put whatever I want in my array, which is very, very loosely typed. There's very unstructured for some people, but very flexible as well. So if you create one array, right, you can have everything inside of the array you want. Why? Because now that array is an object, because everything in JavaScript is an object. So even though I say my array is equal to a new array, what's an array? It's a class. It's a built-in class. Think of this as a built-in class, just like objects is a built-in class. And now my array has certain properties, right? I can do this. My array 0, which is the zero-based indexing, is equal to first. Here's my key value pairs again. I'm back to this stuff. I can assign a value here in my array. I can also use the concat method, right, to actually add a third value. It adds it onto the end of the array. So first, second, third would be my array now. right? That's what my array would be. I can do that when I concat. I use the cat method. And here's my first array, 51 and 67, and I have 18, hello, and 125. And if I concat my first array, when I use my concat method with my second array, I put them together, right? Concat. You might see that. That's a very common way of doing things. But you can also use the plus operator to do the same thing. You have one array, and you plus the other one, and then now they're together, right? Here's another one that you may see. Join also is very similar to concat, right? But the join method converts all the elements of the array into a string. Now that is useful. If I want to make sure that every element in my array is a string, no matter what the data type was before, I use the join method. Guys, you need to know these things because these little methods for the arrays we're going to go through right now are the key things that you're going to use to manipulate your aliens and your clouds and your explosions and everything else that we're going to do. If you don't know this, right, in JavaScript, then you won't get what the notation is when I show it to you. You're like, Tom, I want to die. I want to stab my eyes out. What is that? You know, remember, it's arrays, and we're using this join feature, and this is what it does. Push adds and pop removes elements, and it removes elements from where? From the end of the array. And there's also another couple of methods, unshift, which adds, and shift, which removes and adds elements, respectively, to the top of the array, to the start of the array. So it's almost like you can control the where you add or remove stuff from the array, right? Why would this be important? Well, imagine we're using Create.js to create a display list. And our display list for Create.js, everything that gets displayed in the canvas is just an array, a list of objects that we're putting on the canvas. Well, I can use these things because my display list is an array, right? So I can do, I can use shift, I can use unshift, I can use pop, I can use remove, I can do all these push and pop to change which part of my display list I'm removing stuff from. But I think the better one, if you're going to do anything at all, is this slice method. And you're going to see this used a lot. What slice does is it takes wherever the position is of the object in the array and removes it. It pops it right out. In Java, it'd be like the remove command. When I actually remove it right from the middle of where it is. And what it does is it joins the other two ends together. So here I have my array, and let's say I have this part of the array that I'm not going to remove, and this part of the array, the left side and the right side of my array, and in the middle I'm going to splice something out, right? But what happens with the array, it becomes concatenated in the middle. So now it's one continuous array again. So I can pop an item out of there using slice. And that you're going to see a lot more. So for example, star.slice13, right? If you notice it starts at 0, 1, so I start at denib, right? And I go until 3, but not including 3. So I go denib vega, right? I don't include 3. This is my stopping point. This is start and stop, not including stop. And then I take these two elements and I pop them out of the array. And what I do is I don't actually change my star. My star array remains unchanged, right? But I can create a new one. Almost like a substring. I'm taking a string and I'm using my substring command and I create a new one. It's very important to know these things. I'm showing them to you. This is a reference card for use. We're going to see these things over and over again, and that's why I mention them. I wouldn't bring them up if you don't need them, right? Sort is also interesting, but remember it does weird things. If you try and sort numeric values, it will mess you up, all right? Do not do such a thing with numeric values. It does things alphabetically, and sometimes if you try and sort something like 1 and 111 and 112, and if you had some other things like 2, if that was your numbers, 1, 111, 112, and 2, you would think it would be 1, 2, 111, 112. But no, it's not true because alphabetically, 1, 111 is next, and then 112, and then 2. That's actually a sorted order, right? Because it doesn't sort that way, yes?
Does it have sort on that?
Sorry?
Sort on.
Sort on. No, but you can adjust the sorting methods, so you can do different ways. You can do ascending, descending order. You can change. If you actually go to the sort method online, it'll tell you different ways of adding additional parameters to the sort option. Okay. Iterating through arrays is really important. We've tried this before, and you can use the for method to do that with the dot length. You want to go through the array length. So it's less than the array length. It'll iterate through the entire array. This is a very common methodology, right? Here's a JavaScript class example, and this is where we actually finally use the way we normally look at classes, with this prototype syntax. I'm not going to go into the prototype syntax too much because I'm hoping you'll join me with TypeScript, right? If you decide to do JavaScript and pure JavaScript, this is the way it would look. My person class, function person, with my first name, I'm passing a parameter. And this dot first name is equal to first name, which is normally what we would listen for, right? And then if I want to create a method outside, define a method outside of my class, I say person.prototype, prototype being a keyword that's included in JavaScript. Person.prototype.sayHello, that's the method name, is equal to an anonymous function that has this body. That is the syntax to create a prototype method for this prototypical language. And of course, you'd use person1 and person2 the same way that you would use it in other languages. And now we'll stop there before I get into TypeScript a little bit more. And I'll pause there because I want to talk about other things. But I think that's a good place for us to take a 5-minute break and get a little bit of, do a little bio break, and then we'll come back and continue.